Hello, my name is Dalia Chernarita and I am an associate professor in Kaunas University of Technology. In this video, I will talk about complex systems in informatics. In general, complex systems have many components which affect each other at many different levels. They can be described as networks with many nodes and links. The relationships between the components are nonlinear, thus the components can be analyzed in an isolated environment. Also, there's no central control in such systems. Another important feature is adaptivity that enables to solve problems in local level. Complex systems in informatics are usually analyzed from the point of data transfer process, as data is created and shared between different systems. Nowadays, data is generated with high velocity, volume, and variety. This type of data has a special title, and I'm sure that you heard about big data. To understand how complex systems work, let's visualize a part of complex system as a storyline. Here you can see separate components of a story, but let's connect them into a sequence. Let's say a student named Anne wants to visit a museum in the capital city. She knows that there is a very interesting lecture at 5 p.m. and she wants to participate in it. She takes her phone and learns that there are several options to travel to the capital, that is, to go by bus or by train. Anne visits the websites of bus and train companies and decides to go by the train. She shares her plans with her friends by sending messages and making phone calls. She buys train tickets using the railway app. As she arrives to the capital early, she can visit a castle and have a cup of tea with her friends. Later, she takes a taxi, pays for the trip, and evaluates the service. When she arrives to the museum, she buys museum tickets and participates in the lecture. She needs to take a bus to go back to the train station, so she checks bus itinerary, and as she does not see the bus coming, she writes a negative comment about the city bus being late. As she goes to the train station, she buys train tickets again to go to her hometown. And when she goes home, she turns on the computer and comments about her impression on the lecture. She has pictures and videos on social networks. This journey generates data of various types and forms. That is, there are data items generated while paying bills, making calls, sending messages, giving sentiments, browsing websites. There's also textual data in the form of comments and visual data as photos and videos. The data is stored in databases and can be used to detect changes in client behavior, analyze popularity of events and places of interest, identify itinerary fails, and many other things. To better understand the patterns that appear in the big data, various visualization techniques are applied. They are mostly based on several principles of visual perception, which you can see in this slide. For example, in the image A, a group of objects form an object. I'm sure that you can see that the square that is formed out of 9 smaller squares. Secondly, humans' brain tends to finish objects although they are not there, and this is shown in the example B. Another example is given in the image C, as objects of similar shape are recognized as a group. And here we can see 3 groups of different shape objects. An example of object extraction from background is given in image D. Most of dashboards are created using the principles which are shown in image E, as human understands that bigger objects are more important, especially if they have bright colors. Image F provides an example that humans tend to group objects if they are connected, and this is very helpful in visualizing complex systems as networks. Also, humans are perfect in detecting errors and not. These and even more principles are applied in big data visualization techniques. Here we can see a bubble chart, and the bubble size and color represent certain features of the data item. Similarly, bubble size on the map can represent indicator of a country as given in the example on the right. If data consists of textual information, an interesting approach is to use word clouds. It's also possible to use parallel coordinate charts and rule charts to help to analyze multidimensional numerical and categorical data. To sum up, analysis of the complex system in the form of a storyline and appropriate form of visualization can help to identify relations between different components and patterns that appear in a complex system. For more information on teaching complex systems and systems thinking, please visit project's website.